This next lesson focuses on isosceles and equilateral triangles. So it focuses on some of the different properties, I guess, pertaining to what was in the last lesson and how that kind of translates over to an isosceles triangle and how it translates over to an equilateral triangle. So an isosceles triangle and an equilateral triangle. If we go back and look at what those are again, an isosceles triangle has two sides that are congruent to each other. And then on an equilateral triangle, all three sides are congruent to each other. If two sides of a triangle are congruent, then the angles opposite them are congruent as well. So technically you could say, and this is the base angles theorem and its converse. So technically you could state that if you have a triangle and two of the angles are congruent to each other, you know for a fact that it is an isosceles triangle, and that's because the two sides opposite those angles would be congruent to each other. And then same thing, if two angles of a triangle are congruent, then if all of the angles are congruent to each other, then you know that you have an equilateral triangle. So here's a picture of what I was talking about on that previous slide. If I know that two of these base angles are congruent to each other, I know for a fact that these two sides are congruent to each other. I know for a fact that this is an isosceles triangle. All right, that's what this was stating right here. Isosceles. Helps if I spell it correct. And then for the equilateral triangle, if a triangle has three equal sides, it's equilateral. But then it is also equiangular. So if a triangle is equiangular, then it is equilateral. So that would be the converse of that statement. So which angles are congruent here? Here's an example of possibly an isosceles triangle, or possibly an equilateral triangle, but I know for a fact that this would be isosceles, and that's because it's showing that these two sides are congruent, so I know for a fact that it is isosceles. So which angles would be congruent to each other then? Well, according to the picture, I know for a fact that angle P is congruent to angle R. And that's because those are the angles opposite those congruent sides. Find the measure of each angle. If this was 50, I know that these two angles added together would have to equal 130. Well, I know since they are opposite these congruent sides, I know for a fact that both of these angles are congruent to each other. So since both of those angles would equal each other, then all I need to do is divide this in half. Take 130 degrees, divide it in half, and I find out that these two base angles, so angle X, I find out that angle X, the measurement of angle X would equal 65 degrees. And I also find out that the measurement of angle Z would equal 65 degrees as well. Find the values of X and Y. In this picture, this is an equilateral triangle on the left. Therefore, I know that the length of this segment would equal 7. I know the length of this segment would have to equal 7. So X is equal to 7. The triangle on the right, I know for a fact that it's an isosceles triangle. Because these two angles are congruent, that tells me that this side is congruent to this side. Congruence means that their measurements equal. So since they are congruent, that means that I should set them equal to each other. So solve that out, and I find out that y is equal to 3. So x is 7 and y is 3 in this diagram. All right, hopefully that gave you a bit of an understanding of what that base angles theorem is. Basically, it's talking about the isosceles triangle, the equilateral triangle, and how they have congruent angles and they also have congruent sides.